Okay, so picking back up where I left off. For Kubernetes, when we're thinking about using a hosted to non-hosted cluster, there's going to be some differences. So when we're thinking about how does that look from a threat modeling perspective, right? What changes for us? So if you can see here, I'll zoom in. I put together a attack tree, essentially mapping out all the threats that I see from the Kubernetes threat matrix. I have this hosted in a GitHub repository too, so this is a better visual. This is essentially a repository I've created, but this will have much more in the future. Key node policy as code. This is to help you understand security holistically, right? Across Kubernetes, but any type of technology that I'm going to cover. I want to ensure I don't just give you set and forget type of stuff and make any assumptions, right? I want to make sure we all learn together. So Kubernetes I'm a little bit more familiar with after doing CKS. This made me pretty proficient to have a more nuanced understanding of this. And then exploring further, this is one of my passions is open source security, but also making sure organizations are adopting this type of technology securely, right? So at a high level, we will reference this attack map as I'm using a pencil. I'm trying to get the hang of it, but this is essentially allowing me to manipulate. If you can see me struggling, that's me changing from the pencil to my mouse traditionally, because I'm still getting the hang of architecting with a pencil tablet feature, okay? So at a high level, we have our privileges. That our ultimate goal in this image that you see described here is to gain privileges on a cluster to cause a lateral movement discovery, right? Now, broadly, this is just compromising the cluster, okay? So we want to think about what are we doing? What is our intention, right? And then what are all the ways we can defend against it? So then that's going to branch out to all these smaller areas here. Now, I added external remote. That's why it looks a little janky right there. So bear with me. External remote access is, it's likely you have a large set of developers that need to make changes to your cluster, right? There's a number of ways to handle this. The best way I've seen with enforcement of zero trust is using a service like, I can't even think of the name of it. I've covered this before, but essentially this creates a portal that has the kube configuration and RBAC access that is externally able to enforce MFA, SSO, things of that nature through a browser. So not necessarily exposing the cluster outbound to a larger surface, right? I'll get into how that kind of looks as well. What's the experience as we progress throughout this series, right? So I wanted to cover how we would map such a very misunderstood type of technology, right? But to get you more accustomed to, at the high level, what you should be thinking about if you're going to implement this. So I'm going to start traditionally where every conversation starts at permissions, right? We've heard of privilege creep indexes, cloud infrastructure entitlement management, or KEEM, right? And if your KEEM that you are using in your organization, and I'll spell all this out so it makes sense, right? Let me see if my pencil will spell it here. Kind of nice for you. Let me manipulate this. So KEEM broadly, and that's really sloppy, so we'll just go through with the typing. KEEM essentially is your cloud infrastructure entitlement management. Why is this pivotal, or why is there another tool per se? This is to help you gain visibility across all the API permissions. In a nutshell, the difference that you're going to see specifically with Kubernetes and these orchestration type of layers, right? What are the challenges? We call these those day two operations, right? Or paved roads is from the security aspect. The key areas that you want to understand, at least substantially what I see through cloud security, biggest risk are highly privileged dormant identities. If those identities are compromised in any shape or form, right, and they have read or write permissions, particularly write, that they can alter certain underlying APIs, that's where your real problems start to occur, let's say, broadly speaking. Now, this is a huge area that a lot of organizations are trying to understand. Maybe you're getting started in using containerization as far as the application, and perhaps you're thinking, should we do bare metal Kubernetes as an organization? Are we ready for that, right? Or do we need a more, what I call buying a new home type of option, and that's going to be your hosted services, AKS, GKE. Makes it fairly simple, along with EKS too. In terms of complexity, I would say EKS requires a little bit more uplift and sort of turnkey. It's not that, oh, I think one's better than the other. I think this one assumes a little broader maturity on understanding Kubernetes before you use it to its fullest extent, at least from my perspective. I've trained in all three. I think the better experience, at least for me, is Google Kubernetes Engine, and Azure Kubernetes Servers probably be number 2 for that. So again, just my opinion, before I get any mean comments in the chat. So, broadly speaking, there is 2 ways we can manage those permissions. So when we think about containers that are highly privileged, right, we know that there are certain rules or enforcement policy admission controllers that we can have check before a certain operation is deployed. One way to prevent elevated privileges from a container, right? So we think of not running as root in the container, abstracting that away. And that's going to also go into how we build our images as well. Ideally, you want to use some form of checks, right? And those checks can be, broadly speaking, that could be conf test using like OPAs, Rego expressions. And we can go a little bit further into that, no worries. But just at a high level, I want to keep this very consistent so everyone can understand. So if I lose you in any shape or form, feel free to always leave a comment. I'm always trying to get better to make sure that I can speak clearly to a lot of these complex areas. So let's start at the left and then we'll work our way to the right. And then I'll break down what are the defenses that we have. And then I'll visually move around down here and add as needed, okay? So the first one, typically you have to look at your reality. That's up here where it said hashtag unsecure. So if your API server is exposed, this is saying I can enumerate, Kubernetes operates at port 6443. What that means is I can enumerate and discover quite a lot from just that port. A well-known organization, Tesla, was exposed through a Kubernetes dashboard years back. The Kubernetes dashboard is not necessarily enabled out of the box. There's a lot more secure ways to manage those, but you want to think about the Kubernetes dashboard is what you're getting abstracted to through the cloud providers. This was a native capability that was not necessarily thought with the best interest, but also the security around it was evolving at the time. I'm not shifting blame, just saying we don't want that, right? Primarily because our key control plane when we're thinking about operations is going to be that API server. The API server essentially manages or pushes out and tells the other nodes inside our cluster what to do per se, whether that's workloads related. Essentially, you want to think of it as the nucleus or the brain of the orchestration platform. So typically you'll see here, and I'll show because a lot of people are adopting this type of technology, AKS security practices, what we talk about in some of the best practices for cluster security. So broadly, you can see here I'm accessing Microsoft documentation just because I know we talk about the cluster API access. So this is a very old drawing. You can see from the old deprecated logos, but the authentication prompt of the first kubectl connection. So some people will say kubectl. When we provision our cluster then will produce essentially our credentials, right? Our credentials that are stored in a kube config. And that's essentially what we're telling the cluster, hey, here's my pass and here's my access with that pass. So that's essentially going to go back to the API server. It's going to validate that. You'll see cloud providers, whether that's Azure, Google Cloud, EKS for that, to push for what we call using the native protections of that underlying platform. What that means in a nutshell, right, as far as when we're thinking about RBAC broadly, is you can extend some of the capabilities of what is known as Entra ID, right? If you have conditional access and more native functionality through the cloud provider. This is, again, going to extract this from the user, but I just want to break down, perhaps that doesn't always work for every organization. It just really depends on how you want to structure your cluster. But you'll see restrict access to the instance metadata. Every cloud provider, I'm pretty sure I could look this up for Google Cloud real quick or EKS. This will likely call this out. And the reason being is because for every type of instance that you are deploying, blocking access to the instance metadata, this is a risk. You don't want this exposed. And the reason being, and you can see this is AWS's GitHub, similar, right? You can block access to instance metadata by requiring the instance to use IMDS v2. This will show how that looks, right? And it'll talk around how you do that. And then this goes into more programmatically how we look at YAML manifest as well. And then some of the key areas that we talked about. So having that specific container, right, in that pod ran as a defined user in a group, and then having that container, right, with some commands, but then we also have any security context related to FS group. Now, obviously this organization or any organization has some type of legacy technology, right? The biggest piece that I see a lot of people struggling with day two operations is keeping their node images up to date from their control plane. Luckily though, the benefit of you moving from a traditional bare metal cluster to a hosted, you get to have the upgrade process really abstracted to you. This is highly beneficial to your ops team because it's likely they probably haven't built automation around it, but B, the way Kubernetes updates is another, gotcha if you don't know what to look for. Okay, so you can't go from we're on 1.290, right? And now this is already as stable. I couldn't go from 1.290 to future versions outright of like 1.32, right? If I'm using a traditional kubeatom. The way it works is I would have to upgrade to 1.29, let's say, or 1.30, like as a major release, and then let's say it's 1.3, 301, whatever the case may be. I can only go one at a time, okay? And that's one of those nuances. As you learn this platform, you'll understand kind of the pros, the cons. That's one of those I say it could be a gotcha if you don't know that ahead of time. But anyways, long story short, let's go back to the topic. We don't want our API server exposed. So what are the methods that we should consider? So typically you can have this in a couple ways, and any type of Terraform code, right? I'm only going to this from an IAC pattern, but also this could be, we could do this, through Bash, wherever, Azure, CLI, etc. We have access modes in the cluster. We recommend, most vendors and also security practitioners should have this abstracted, right, through a private endpoint. This is known as a private link in Azure. It's likely a similar nuance. I have to dive deeper in EKS for that. But just at a high level, you want to think about this as you have your virtual network, regardless if that is a VNet, whether that is a virtual cloud network, whatever the case may be. Your virtual cloud network. And you want this to be isolated, right? Where it still has outbound connectivity, typically through some egress or ingress controller, right? Most commonly you'll hear Nginx used for this, right? And then if we want to manage some TLS certificates, things like that, we'll likely do a cert manager, etc. That could be Let's Encrypt, etc., etc. And we can go down further in those paths as well. But in general, you want this abstracted. I don't think this is talked about enough, how much that these are exposed, right? So if we went to shodan.io and looked for Kubernetes running on this port, you'd be surprised how much you could find from researching and threat intelligence that this is still going on. So if you deploy from the command line without an access mode defined, you could already be exposing your cluster to the wide open web, right? There is what I call a more secure way, but I wouldn't say it's the best secure, right? More secure in the sense, if you have authorized IP ranges defined on the cluster. So this will essentially lock down the control plane to your private IP or public assigned IP. But you could do this as a /32. Whatever the case may be. You could have that wide open, you could have it as narrow as you want. Now, this is not to say I recommend this in production. However, if you're spinning something up real quick, you're trying to test something, how does that really look, right? Those are things you want to think about. And what I'll do to help illustrate some of this is I can switch over to the command line and then show you as I go. So when we're looking at the next area, we're going to have to understand what type of access our API server communicates on, and then how locked down is that API server, right? What type of encryption? These are a lot of customizable things that can be changed, and this is all part of the documentation as well. So that's step one. Step two, we want to think about, okay, from the container admin command, broadly speaking, if a container has admin privileges, right? Container set privileges elevated, and then how we reduce the surface, and then it's a feedback loop, right? So when we have this larger item, container admin command, we want to think about this as a policy as code. Hopefully you have some type of admission controller, whether that's native through the cloud provider. They typically will call this constraints or something similar, just depending on who you're using. And this will open up tools like OPA Gatekeeper, right? You'll see Azure policy runs on this natively. Google GKE probably has something similar. So those are going to be the policies of enforcement for certain operations in the cluster. Now, these are not to be confused with your network policies, because this is just one layer, right? We have to think, depending on your CNI, and I can see if we have a logo for our CNI, that is going to be a huge component too that you want to consider what CNI you're deploying. It's likely you have heard of Calico and Cilium, right? Cilium is more of a de facto now. Calico is still prevalent. You'll likely hear about external Berkeley packet filter running at eBPF. That's a little out of scope for today, but just so you're aware, right? These are going to be some decisions that you're going to have to make. No, that's not it. So I don't have an image to represent the CNI. And the reason being is because depending on what CNI you deploy your cluster to, this is that container network interface, right? The virtual network firewall rules, things of that nature, if we're going to place a WAF in front of it before our ingress, our Nginx ingress controller, things like that, we're going to have to really understand, if our CNI is able to scale as our organization grows, but maybe our cluster is going to get larger over time, right? The reason being is because depending on your CNI, it can give you native capabilities to that cloud provider. Most of the time, EKS, I believe, is on Cilium, AKS natively. So if you run the creation of a cluster, this will tell you what CNI. These are all pluggable and changeable. So it does not... the world's going to end, things like that. But you have options is what I'm saying. So we'll get into that next. So we want to think about using tools like OPA Gatekeeper here to reduce our privileges. Now, you've probably heard of Kubernetes as well. You can use that as a policy controller. Really, this is really up to you, but you want something to intercept any of those API calls that we issue, right? A kubectl apply for those manifests. And what is going to be the enforcement mechanism that's going to prevent and check for some of those best practices, right? So then we go back to the cluster access as well. So we can have a user that's impersonated, right? So this could be someone that does gain cluster access, whether that's a kubeconfig that is mishandled, right? You want to think about a kubeconfig in general, and I think this might be better too if I kind of switch gears. Let me run up a killer coda. Let me check out their scenarios and make sure I'm logged in. Because I think a lot of this will be better if I demonstrate hands-on what I'm talking about, but B, then go back to illustrating how that looks as well. And it looks like we're getting, okay, playgrounds is what it's called then. So this can give you a base environment, and the reason I cover this tool a lot is because I use this for my own type of sandbox. You can use this as a sandbox to explore using kubeatom as well if you don't want to use Minikube or anything locally like that. If you're trying to be on the go and test something out real quick, this just works out a lot better. But sometimes it does lag, but it is free. So I'm always going to let you know what what's out there so this can help you out. So once this loads, we'll come back here. We can see it, give that some time. The cluster access itself, if a admin token is used or spoofed, if you will, to access, that's going to be a direct area. So you want to think about the cluster access as a cluster role of someone that's highly privileged, how that would look. But B, how does that, what are we defending against? Do we have conditional access set on that specific cluster access? Do we minimize that access to only a subset of users or a user, right? Ideally, a smaller scope, the better, because then we don't have that many trails to follow. But those are going to be the large ticket items that are really going to open you up to risk. The next area, container resource discovery, right? The way you have this is container manifest misconfigured and exposure of assets inadvertently. And this really relates to A, this would be the privileges. B, this would be any misconfiguration aligned to the container level itself, right? So what would be the big picture of that? Exposure of assets, right? This is a key area that still, right, regardless, it's just like S3 buckets and storage accounts should be private, right? Without guardrails in place, this can happen fairly quickly. You'd be really surprised. So that's the reason why you see me harp on it. But B, I don't want the same lessons repeated out there and hurting other people, specifically with the data that's hosted as well. So another area that we want to think about is exploiting public-facing applications, right? So if we do have a public application that we are going to expose from a pod, right, on a certain node, we want to think of the node as a boundary, right? Perhaps we have a Windows node, right? This could be Ubuntu, this could be Windows, whichever the case may be. Let's say we have certain workloads that we know are going on this node specifically, and we want to make sure that that is validated either through labels, a node select, or whatever the case might be, just for that node, right? And let's say we run more sensitive operations, i.e. training data, whatever the case may be, for some machine learning models that, let's say, is proprietary to our organization, etc. Those are going to be areas that you don't want a public-facing application on a certain node or pod overly exposed without some rigorous abstraction in front of it. Typically an Nginx ingress controller, right? Or an app gateway, plainly speaking. The reason being is we can enforce a lot of those layer 7 protections, and we also don't have it directly accessing the pod itself. Any case it may be, you want to keep this abstracted away, right? So similar to how we would have a application inside Azure, Google Cloud, etc., we would have this configured where we have, front-facing website, typically with a firewall, load balancer in front of that, and then it's distributing to the actual resource. It's abstracted away from the user, okay? So it's not too much of a difference. Let me just refresh while we change environments here. It's not too much of a difference from what we're already aware of, okay? So I don't want you to go with the mindset like, hey, we're not doing this now. B, if you're new to cloud, whatever the case may be, this will all make more sense. Hopefully, if you're already in cloud, hopefully it's easy to pick this up a lot faster, okay? This is just my 2 cents. Next area that we move to are the secrets encrypted. So typically for our secrets, right, those are going to be stored on some container storage interface CSI or whatever the backend storage will be. If you are going bare metal, Kubatum, that you will take the CK exam, right? Or if you're going to use K3s, whatever the case may be, you want to ensure that where your secrets are stored, that they are encrypted. If not, they're going to be in plain sight, right? So if I don't have underlying encryption at rest, those are going to be some of those key parameters that you will have to enforce. So you want to think about the level of responsibility is going to go much higher when you're on a bare metal compared to a cloud hosted. This is not to say you have no responsibilities in the cloud. I don't want that as well. But I would say if you're not doing this at the bare metal level, you want to consider how is that implemented on the public cloud side, but B, how are we going to validate that as well, right? So most of the time, when you provision a cluster, this will be the underlying disk. You want to think about this. These are still your underlying virtual machines. The orchestration layer itself is that control plane that's going to tell those group of machines, if you will, what to do, right? And it's much more effective to think of it like that, right? We're not moving too further away from the same abstractions that containers are. We're just managing those containers similar to like virtual machines, but with one single area for that orchestration layer, okay? So don't want to lose that. Now, we do need to talk about software security, right? That is a huge risk that you're going to hear quite a lot. Specifically, I think cloud security is a sub-discipline of application security because you likely deal with application security every day. And especially in cloud, it really makes that bridge to development and security that much closer because there's a lot more controls that you should put in place and guardrails, right? So primarily we want to think about the image security of the container images we're going to deploy. So that's going to be accomplished in a number of ways, whether you're scanning your image, right? The container image itself is essentially layers. They could have potential CVEs and things like that we want to be aware of. Most notably, a lot of people use Trivy, this by Aqua Security. This is open source, not to say you can't use closed source, but there's some larger ones, or Docker Scout now does this natively through Docker Desktop, etc. And you want to think about, and I'll show you too what Trivy looks like in a second. But similarly, when we go back to our control plane, so hopefully, okay, so it finally worked, and then it restarted. It wouldn't let me access. So let me try that again. But in the background, if we go to Trivy real quick, Trivy, we can go to their home screen, and it looks really nice like this. You'll see Trivy's latest release, and then I'll have its GitHub repository, right? Now, if I wanted to scan any, and this will just do quite enough for here, but this will show what it's looking for in a file, right? Misconfiguration infrastructure as code, but this also scans images, and it's very, very fast. So we can see Trivy image, Alma Linux, 0.8, what are those vulnerabilities, right? And then you can see specifically, and then it'll tell you if it's fixed or not. Now, if I go to Git Trivy, right, it will run through a specific line item down here. It talk about Trivy's usage, so as you can see, that same syntax for scanning that. And then it also scans your Kubernetes cluster as well, and it can build out a bill of materials. So the reason why I say these are going to be areas you want to consider is because we can see here, let me just clear. Let's do kubectl get pods, right? So there's nothing that I deployed. So this is a plain vanilla cluster. So we can see we have our kube system. We have in that namespace all the essentially back-end operations that are needed to be ran. Our API server, our control plane for etcd, right? Our kube proxy. And then typically this will tell you what CNI is running. This should be Canal still. And then we have Calico as well. So let's dive deep into that. So if I do like an ls, right, we can see we're essentially here. Let's cd etc. So then we can go see. It's been quite a little bit of time since I messed with it here. So now if I go into the Kubernetes folder, I have a couple areas. You're primarily going to be tested if you do the command line exam on operating the Kube API server. And the reason why I'm showing this is, A, we can validate some of our assumptions already from our threat model, right, at a high level. And we can look at what is in place right now. So this is going to give you a high level of the annotations, right? The Kube API server at its heart is a pod, right? Now this will tell you certain type of configurations that we're enforcing, right? So this will tell you where the etcd certificate authority file is at, the cert file, a key file, and where etcd is at, right? So loop back in here. This will tell us our kubelet. And then as you can see, that port 6443, that's going to map right back to what I talked about, that exposure, right? So that's what Kubernetes listens on. And then our service cluster range, we can see we're pulling the latest API server. So the reason why I'm showing this is because there is that software supply chain security, right? So when you're using a hosted, whether that's EKS, AKS, whatever the case may be, this is the cloud provider's responsibility, right? The difference that you want to be sure of when we're thinking about a software bill of materials and understanding if there's any underlying vulnerabilities in an image, right, using tools similar to Trivy, is because these components are what make up your cluster. So if one of these components had an underlying vulnerability, right, those are going to be some risk that you're essentially assuming until that provider in the cloud notion, protects that. So those are some things that I'm seeing, but also I don't think are too stressed yet, because it's still a relatively new going that far in detail, right? And I can show you, I believe when I had this up, we can pull this relatively quick. So I'll run we can run this as a container, or we can just run with a script. I'll install from the source. I'll go back here. Now let's get out of here. But if I was going to do any changes here, this is pivotal, right? So let's go back here. We'll run that. We'll clone into Trivy. We'll run that, go install Trivy. And then as we see, Trivy's built on various packages in Golang as well, right? Now this is telling you, since Golang is compiled, this is going to give you the output of all the libraries that make up that specific package, if you will. So as you can see, it's quite a lot, right? So you have some hosted in AWS, you have some, and it's likely pulling from their APIs as well. So just for clarity, you even have a GitHub in the New York Times as a gzip handler, right? So this is the concept. So when we're thinking about open source, this could be made up of a number of components that are already out there in the public, and then it's putting it all out there of that source code as well, that you can even inspect further, perhaps make your own type of image scanner, things like that, right? In any case, going back to our attack tree, so we stay on topic here. When we're thinking about the image security, it's going to start with scanning, right? And that's going to scan our images before they're deployed. Ideally, you want a private repository that essentially has a vetting process, whether that's programmatically or through our CI/CD pipeline as well, right? Our images have to be scanned and match a certain amount, hopefully, of the most minimal vulnerabilities. Hopefully you're using chain guard or a very small image as far as like distro list images, because that's really the best way I've seen to minimize your risk while this installs in the background. We will go back here. So that's a part of supply chain as a whole. You'll hear about software bill of materials as well when you're building an application. This essentially being as transparent as possible. Hey, this is what this package is made of. Essentially, what is the inventory of packages used for said proprietary software or open source software, right? And there's a pretty big push for that. But it's also keen to keep in mind that, broadly speaking, I haven't seen this pick up too much. It's not saying it's going to fix any already persistent issues that your organization might have with application security, but it's another form of transparency even further. So we can see here, let me do clear, and let's just say Trivy. Oh, maybe I need to run it as command Trivy. Let's see. Oh no, okay. So once I install, okay, so let's just go with this. I don't feel like messing around with anything. We'll just install from the source so we can use the command line and I don't have to edit anything. Okay. So if I use Trivy, I can see I have some outputs here. So now let me also make this larger. So we can see right here, what does this look like? And we have Kubernetes, right? So if I do Trivy K8s, let's see what output it gives us. It'll provide at least one argument. So I want some type of argument. Let's do just an entire report and we'll go from there. And I'll show you examples as well that this can notify you if something is violating certain areas as well. Now, again, you want to think about this when we're going back to a layer. This is going to let you know if something is going awry, where that's happening, right? But broadly speaking, it's going to be part of it. So if you're going to see here, once we issue that command, it's going to reach to an outbound database, Trivy database right here. It's going to download that database real quick. It's going to essentially do a search for our configuration, any misconfigurations from that. And then based on that repository or database, a lack of, then our output should be fairly redundant. Now you can see it might take some time. This is completely normal as well, especially when we're pulling, it looks like 45, 43 megabytes, all right? And then just pull a little bit, but it looks like we're hanging there. We can open up another terminal as well, if needed. Perhaps I don't want to mess up this browser session because I always feel like I'll lose my area. So when we want to think about IAM, right, that's going to be a focal point for our cluster roles. Now, the way Kubernetes defines roles is broadly you can have this segmented to a namespace or a cluster role that's widely. Ideally, you want to sit right here in a more limited scope, right? And then for the external remote access that we talked about earlier, that's going to be using certain tools like Paralysis. Let me show what Paralysis is. I did a video on this, but this essentially acts as a proxy, if you will, in between your clusters. So one place to manage all Kubernetes access. Once you essentially use this tool, you essentially add clusters through typically their own custom backend. You have your kube config hosted here, but then you also can segment levels of access through a user interface. So i.e. if I needed to access the cluster in a CLI or on the web securely, I could use a tool like this. This covers a lot further. There's obviously an open source portion of this, and there is probably some other providers that do something similar, just top of the mind, and tools that I've actually explored with this. It's fairly straightforward. It talks about using your own custom domain, and depending what cluster you're running, right, you'll get pretty familiar with DNS fairly quickly in Kubernetes. So it'll get you much more exposed if you haven't dealt with anything like that. So this one's taking quite some time, so we might need to come back to that. But the big picture, we want to map how can we get back to attacking a Kubernetes cluster? What are some of the risks that exist? And this has been well documented, at least I think so, for the most part by many organizations as far as like a threat matrix. You probably hear this. This is one way. This is not the only way, right? Similar to what I showed on that last video as far as a threat model, you can consider this one area. Now, again, this article was written back in 2020. It's updated in 2021. I can go here, and I think we have probably something even further. Threat matrix for Kubernetes. Okay, that's just a redirect. So let's see here. So this talks about how this looks from the MITRE attack framework. So similar, right? Initial access, that's going to compose of that kube config like we spoke about. A exposed dashboard. This is deprecated now. Exposed sensitive interfaces, new technique away. So there's things being added. This is a fairly new type of technology, 1.29. I mean, it's been out there for quite some time, but organizations are now starting to pick up on it. The instance metadata that we touched on from a discovery asset, right? Access to the Kubernetes dashboard as well. Now, when we're looking at exposed dashboard, it doesn't mean that Kubernetes doesn't have a dashboard still, but this is saying from the discovery perspective, this is where it's moved, okay? This is deprecated as initial access. So just so we're clear there. Privileged containers still exists. Cluster admin binding, host path mount. What access to those resources? Let's go right back to your permissions. And then malicious admission controller, that could also be a threat. Now, again, this will tell you what's been deprecated, why it's deprecated, what Tiller is. Tiller is a part of Helm. It's essentially, you want to think about it, well, that's a whole different conversation. Anyways, this will tell you new techniques for the threat matrix. And you can find quite a lot from pretty known providers in this space. I think you'll see Lacework. They make a product, so no, I don't want to go too much in the product side, but just so you know that that's how those tools are operating based on as we learn and go, how the threats evolve. Because the attacks specifically for Kubernetes are constantly changing, therefore when we do an upstream, whatever the case may be, so it looks like deadline expired there. So let's do something smaller. I just want to show you this output. So we'll just do a namespace. We'll do our kube system just so we know from that. Let's see if that loads again. This should be much smaller since we're limiting it to, hey, don't scan my whole cluster. Now just look at the namespace kube system. So it's likely going to run a report based on YAML, looking at a lot of the areas that we talked about. But B, if there's anything I should be concerned with, this report typically will summarize it. The reason why this tool has gained a lot of popularity is because it's already endorsed by the CNCF. Aqua Security does quite a lot for the community at large. So I definitely want to say thank you, Aqua, if you're watching this. Please throw a sponsor over here as well, if you could. But I'm a huge fan of their tool. You will likely get more familiarized with this if you're doing certified Kubernetes security. This is one of the larger tools that is being used in that one. Now I'm going to let this video hang. I don't want to. I'll stop this recording if this picks up in between from now, and then the next time I'll just start again, but I don't want to let our video hang. I hope this gave you a good overview. I know I went pretty long, but I can go many areas of this. This is just one quick area that I started looking at attack a Kubernetes cluster for privileges, the ways that I've mapped those back to that threat matrix as well from cross-correlating, but also the threats that you learn about and how to protect a cluster writ large, right? So hopefully this helped you understand a more complex topic. If you need this repo, I'll put it in the description. Okay, so it looks like the scan completed. I just wanted to show kind of what that output looked like. So what this does is this will break down your workload summary report for our Kubernetes admin, the workload assessment. This will tell us the kube system, specifically the daemon set, right? This will have each item listed for you in a nice visual. And then this will also color code it critical, high, right? Things that I should be aware of. And then this will also take a look at your RBAC, medium, right? So similar, I think I've done another video on Kubescape that you can reference. This is showing that output of that specific namespace. Mind you, this is just a summary of one namespace. So don't sweat this, but this is just showing out of the box what it's finding, right? Now, it gives you some more details. If you can see here, right, Kubernetes flags, this will tell you all namespaces, exclude owned, right? So you have a lot of ways to configure this. So I just wanted to show that output. Hopefully this helps out, give you clarity.